What if aging was not inevitable? What if it was a disease, one we are already learning how to cure? In laboratories right now, scientists are not just slowing aging down, they are reversing it in mice, in human cells, and in some cases in people. This is not science fiction, this is happening, and the question is no longer if we can reverse aging. The question is, how soon? What is aging really? For most of human history, we assumed aging was just what happened. You are born, you grow, you get old, you die. But that assumption is collapsing because aging is not random. It follows rules, it leaves fingerprints, and scientists have identified exactly what those fingerprints look like. In 2013, biologist David Sinclair and a team of researchers published what became known as the hallmarks of aging, a list of biological processes that go wrong as we get older. Things like DNA damage accumulating over time, cells losing their ability to divide, the communication between cells breaking down, mitochondria, the power plants inside every cell slowly failing. These are not mysterious forces, they are measurable, trackable, and increasingly reversible. Let us talk about what is actually happening in the labs right now, because this is where it gets extraordinary. In 2006, Japanese scientist Shinya Yamanaka discovered that you could take any adult cell, a skin cell, a muscle cell, a brain cell, and reprogram it back to an embryonic state, basically rewinding its biological clock to zero. He won the Nobel Prize for it. But the problem was, when you fully reprogram a cell, it loses its identity. A skin cell forgets it is a skin cell, and that causes cancer. So researchers asked a different question. What if we only partially reprogram the cell? Turn back the clock without erasing its memory. In 2023, David Sinclair did exactly that. His team used a modified version of Yamanaka factors to restore vision in old mice. Cells that had aged and lost function started behaving like young cells again. The mice could see again, not slowed down, not maintained, reversed. Second, senolytics. As we age, certain cells stop dividing but refuse to die. Scientists call them zombie cells or senescent cells. They just sit there, releasing toxic signals that damage everything around them. Senolytic drugs are designed to hunt down and destroy these zombie cells. In animal studies, clearing senescent cells extended healthy lifespan by up to 36%. Human trials are underway right now. Third, NAD+. Every cell in your body runs on a molecule called NAD+. It powers DNA repair, energy production, and cellular communication. By the time you are 50, your NAD+ levels have dropped by roughly 50% compared to when you were 20. That drop is directly linked to aging. Researchers are now testing NAD+ precursors, compounds that boost NAD+ back to youthful levels. Early results in humans are promising. More energy, better cognitive function, faster cellular repair. These are not three random discoveries. They are three pieces of the same puzzle. The biological age revolution. Here is something that changes everything. Until recently, we had no way to measure aging precisely. Your chronological age, the number of candles on your birthday cake, tells us almost nothing about how old your body actually is. But in 2013, Steve Horvath developed something called the epigenetic clock, a way to measure your biological age by looking at chemical markers on your DNA. Two people who are both 50 years old can have biological ages of 38 and 62. Same chronological age, completely different bodies. And here is the extraordinary part. Those markers are not fixed, they change based on what you eat, how you sleep, whether you exercise, your stress levels, the medications you take. Biological age can go up and it can come down. We are no longer passengers in the aging process. We are starting to get our hands on the wheel. How far can we go? So what is the ceiling? Some scientists believe the human body has a natural maximum lifespan of around 115 to 120 years. A biological wall we cannot break through. But David Sinclair disagrees. He argues that aging is not a wall, It is a program, and programs can be rewritten. If every hallmark of aging is addressable, if zombie cells can be cleared, Natty Plus can be restored, and cells can be partially reprogrammed back to youth, then there may be no fundamental reason we have to age at all. Aubrey de Grey, one of the most controversial figures in longevity research, has argued for decades that the first person to live to 1,000 may already be alive today. Most scientists think that is too optimistic, but 10 years ago, most scientists thought reversing aging in living organisms was impossible too. The goalposts keep moving, and they keep moving in the same direction. The uncomfortable questions. Now here is where it gets complicated. If we crack aging, what happens to the world? A planet where people live to 150 or 200, where retirement as we know it becomes meaningless, where the population grows without the natural ceiling that death provides. Who gets access to these treatments first? The wealthy. Is it ethical to live that long in a world already stretched for resources? These are not hypothetical questions. They are questions we need to start answering now because the science is moving faster than the philosophy. And history suggests we are not great at preparing for things that have never happened before. Here's what I keep coming back to. Every generation before us accepted aging as a fact of life, as inevitable as sunrise, as certain as gravity. And for most of human history, they were right. But we are living in the first moment where that assumption is being seriously challenged. Not by philosophers, not by wishful thinkers, by Nobel Prize winners, by peer-reviewed research, by results in living organisms that were supposed to be impossible. We may not live to see the end of aging, but we might live to see the beginning of its end. So here is my question for you. If you could stop aging at any biological age, what age would you choose? And would you actually want to live forever? Drop your answer in the comments. I read every single one. If this blew your mind, subscribe. New videos every week. Because there is no shortage of questions like this one, and we are just getting started. Stay curious.